Hello everyone, welcome to online course on problem solving C. Today our topic is unions in C. So far we have learned about structures which allow us to group different types of data together. Now we learn about unions which are similar to structures but work differently when it comes to memory. By the end of this video, we will understand what unions are, how they are defined, how they differ from structures, and where they are used in real-world programming. Let us start with the definition. A union is a user-defined data type in C that allows storing different types of data in the same memory location. It is similar to a structure in terms of syntax, but the key difference lies in memory usage. In structures, each member has its own memory location, but in union, all the members share a single memory space. This means that a union can store only one value at a time. Even though multiple members are defined, only one member can hold meaningful data at a given moment. This feature makes unions memory efficient, especially in situations where we do not need to use all data members simultaneously. So now let us understand the memory concept more clearly. In a structure, if you have multiple members like integer, float, and character array, memory is allocated separately for each of them. So, all the values can be stored and accessed at the same time. But in a union, all the members share the same memory location. The total size of the union is equal to the size of its largest member. Because of this shared memory, when we assign a value to one member, it overrides the previous value stored in that memory. So, we cannot use all the members at the same time. We can only access one member whose value was most recently assigned. So, this is the core idea behind unions. So, let us now look at the syntax. So, to define a union, we use the keyword union followed by the union name. Inside curly braces, we define its members, just like in structures. So each member represents a different type of data that the union can store. Finally, we end the definition with a semicolon. The syntax is simple and very similar to structures, which makes it easy to learn if you already understand structures. See the example. So we define a union named employee. It has three members: ID, name, and salary. These represent different attributes of an employee. Even though it looks similar to a structure, the important thing to remember is that all these members share the same memory space. So, if we assign a value to ID, then assign a value to name, and the previous value stored in ID may be overwritten. So this example helps understand how unions behave differently compared to structures. We'll have the differences between structure and union. See, for defining structure we use struct keyword. For defining union we use union keyword. Structures occupies more space than union. Unions occupies less space than structure. In structure we can access all members of structure at a time. In union we can access only one member of union at a time. Structures allows separate storage space for its every members. Union allocates one common storage space for all its members. Union find which member need more memory than the other member, then it allocate that much space. So if your goal is to store multiple values simultaneously, structures are better. If your goal is to optimize memory usage, unions are the better choice. Let us now understand the given program. In this program, we define a union named employee with two members, ID and name. Then we declare a variable E1. First, we assign a value to ID. After that, we copy a string into name. Now, since both members share the same memory, when we assign the name, it overrides the previously stored ID value. This is why unions behave differently and must be clearly carefully. See, now we'll got the output like the program prints both the ID and name. The name is displayed correctly, but the ID shows a garbage value. This happens because the name occupies more memory and overrides the ID value in the shared memory space. So this example clearly demonstrates that unions only the most recently assigned member that contains valid data. So like structures for unions also will have advantages and disadvantages. When coming to advantages, first one, memory efficient. All the members share the same memory, so a union uses only the size of its largest member. Useful for different data representations. You can store different types of data, int, float, char, etc. in the same memory location at different times. Suitable for low-level programming. Unions are helpful in system programming, embedded systems, and memory management tasks. Next, helps in saving space in large programs. So when memory is limited, unions are very useful compared to structures. Not only advantages, we have disadvantages also in unions. The first one, only one member can hold a value at a time. That means storing a value in one member overrides the previous data. Next, risk of data loss. If not used carefully, accessing the wrong member can lead to incorrect result. Third one, harder to debug. Because of shared memory, tracking errors becomes more difficult. And the fourth one, less intuitive. Beginners may find unions confusing compared to structures. So when to use unions and when to use structures in C means in C programming, both structures and unions are used to group different data types, but they are used in different situations. When to use structures. Use a structure when you need to store multiple values at the same time. Choose structure if you want all members to have their own memory. You need to use all variables together. Data should remain independent and safe. When to use union. Use a union when you need to store only one value at a time from different types. Choose union if you want to save memory. Only one member is needed at a time. You are working with low level or memory critical programs. So to conclude this, unions in C are powerful feature in for efficient memory usage. They allow different data types to share the same location, which helps in saving memory. However, this comes with a limitation, that is, only one member can hold a value at a time. Unions are useful in application where memory is limited and we do not need to use all variables simultaneously. As a programmer, it is important to choose between structures and unions based on your requirement, whether you need full data storage or memory optimization. So, I'm concluding that structures helps us to store more data, while unions helps us save more memory. So choosing wisely makes your program efficient and powerful.